Question 9 asks us to differentiate and find where the derivative equals 0. So find the derivative first. I need to turn it into indices, so I'm going to rewrite the question and change the square root of x plus 1 to x plus 1 to the half. Now I can see that I've got a product rule, so I can go the first term times the derivative of the second plus the second times the derivative of the first. Rewrite this first to see what I've got. What I have is 6x over 2, which is 3x, x plus 1 to this power of minus a half means the minus is underneath the fraction and the value of a half says it's a square root. And over this side I have plus 6 times the square root of x plus 1. We're going to get these to a common denominator. So I'm going to write down the terms that I'm starting with. To show you what I'm doing is we want this one left as it is, but this one we want to get to something that's over the square root of x plus 1. I can't just add that because I've changed the question, so I'm going to actually put the times top and bottom by the same thing. So when I put them together, now they're on the same denominator, they can go in the one fraction. Here I have 3x, that hasn't changed. Now I'm adding 6 lots of square root of x plus 1 times the square root of x plus 1 is just x plus 1. Simplify this top line, 3x plus 6x is 9x plus 1 all over the square root of x plus 1. So we want to find where is the derivative of this particular equation equal to 0. So that means where is this equal to 0? That's what we're asking. So this will be equal to 0 when only the numerator equals 0. If the denominator equals 0, we actually have a problem. We have an undefined equation. So we really only want to look at the top part of the equation. So when is 9x plus 1 equal to 0? At minus 1/9. Now it's really helpful and probably a very good mathematical practice to get into the habit of checking then that this value doesn't actually make the denominator, make the function undefined. So we just have a quick glance. What happens when x is minus 1/9 on the bottom? It doesn't equal 0, so therefore we can say that this is a good solution.